All right, day 60. This is day 2 of our exponential equations. And the goal for today's 3-minute review is to solve exponential equations using various strategies. And the typical question from yesterday's stuff, the idea here is we wanted to write both sides with the same base. So we see 2 to the exponent x, so we're going to write this as 2 to the exponent something. Well, and then you got to guess and check or figure it out. It's 2 to the exponent 5, and so we can say since the bases are the same, left and right sides are the same, x equals 5, and we're done. Here, and we saw more difficult ones, but this one I'm going to write both sides as a power of 3. Well, 1/9, I know it's going to be 3 to the exponent negative something since it's a fraction. 9 is 3 squared, so it's -2. And then I can say, well, the powers are the same, the bases are the same, so the exponents are the same, right? It's kind of like the bases are gone, and I'm left with, oops, therefore 2x minus 1 equals -2, and then we're left with a little grade 9 equation. Add 1 to both sides. 2x equals -1, divide by 2 on both sides, we get x equals -1/2, or -0.5 if you're a calculator person. I'm wondering if yesterday during your homework you were thinking about how convenient it was that these always worked out nice, right? This was never 1/10, or this was never 2 to the exponent 30, where it just didn't work out, like this one here, right? I want to write 5x equals 5 to the exponent something, right? But I need 5 to the exponent something equals 12. And notice this isn't easy to do because 5 to the exponent 1 is 5. 5 squared is 25. And then, 12 is nowhere to be found. Maybe it's a decimal, right? 5 to the exponent 1.5. Who knows, right? This is, this is where we're stuck until today. This is what we're talking about mostly today, is these ones that don't work out nice. All right, on to the lesson. And actually, this is going to be a weird lesson because we're going to solve the same question, which this will feel weird. We're going to solve the same question 4 different ways. And we're going to have to sort of pretend each time we do it that we don't already know the answer. So this is very similar to that one that we just had. It says use guess and check. Well, that's what we were kind of doing before, right? With the 5, we said 5 to the exponent 1 is 5, and 5 squared is 25, and then, well, maybe it's 5 to the 1.5, and that's what we were doing. Well, that's what we're going to do with this one. Right? I'm going to set it up, though. They call it sort of systematic trial, is the fancy textbook way. Basically, we're just guessing and checking on our calculator. So I'm going to set up a little table that will sort of organize our efforts. And the idea is that we'll guess and then we'll improve each guess. And when we know when x is 1, 4 to the exponent 1 is 4. It's got to be much higher than that. That was a stupid first guess, actually, wasn't it? So what about 3? 4 to the exponent 3, and I'm using my calculator now. 4 to the exponent 3 is 64, so it's still higher than that. 4 to the exponent 4 is 256. Now I'm using my calculator. I know it's got to be between these, right? And it kind of looks like it's halfway between, so I'm going to try 3.5. And 4 to the exponent 3.5 is 128. Now we're getting there, right? That's pretty good. This is a little bit too high, though, so we might try 3.4. And each guess, we get a little bit closer. Let's try 3.4. 3.4 is 111.43. See, that's a lot lower. We were better off being closer to 3.5. So my next guess is going to be between these, one lower and one higher, but I'm going to guess closer to 3.5, maybe 3.47. that into your calculator, and you get 122.79. Hey, that's pretty good. We're just a little bit high, so our next guess is going to be a little bit lower than that, maybe 3.46. And that's still a little high. Just, oh no, that's a little low. And so the next guess is going to be between these last two. Right? And I'm getting closer and closer all the time. Maybe a little bit closer to 3.4. No, maybe right in between. Let's try right in between. 6.5. Oh, I see now, and we're really close. Say, well, how are we going to get it so it's exactly right on? Well, we're never going to get it exactly right on. If we have all the decimal places right out, we'd have to have all the decimal places right out here, so we'd be here forever. So at some point, we kind of get pooped out, and when it rounds off to the right number, like this one's okay, we'd say the solution is x is about, or that works for about 3.465. Okay, and that's on your scientific calculator, guess and check. The next couple of things we're going to see is using the graphing calculator. And I'm going to set up a sort of split your note in half here. I'm going to do sort of two main methods on the graphing calculator. Okay, the first one is going to be using a graph. This is my preferred method, is using a graph. And by the way, these steps are also in your textbook, if you want to write this down. Example 2 on page 389 is just like this one, but I'm going to show it to you. And then I'll write the steps in. So I'm going to show you what to do first, and then I'm going to write the steps in. All right, there's the calculator. And I've got a bunch of crud left over. The first thing I'm going to do is, for graphs, I need something to graph. And you might have old junk left in here, or you might have these plots turned on. You want to turn those plots off. If you got a black mark up there, remember from last chapter, we'll go up there and press enter to turn those off, and then clear those old equations out so it looks nice. And then what we do is we put the left side into one of these, 4 to the exponent x, and the right side into the other one. And we're going to look for when these two different graphs cross, right? Well, if I press graph, I might have all sorts of crazy window settings, so I'm going to set up the windows. And notice that with a number like 122, I'm going to need these numbers to be bigger. I don't know about the x's. You know, I might have to go back and change these later, but I know the x maximum, or the maximum, the output of this has to be a lot more than 10. I'm going to go up to maybe 150 and have a look and see what that looks like. And I'm not going to go up by ones, I'm going to go up by tens, just so I see that the ticks look better. Those window settings look pretty good. And then I'm going to press graph and see if something good happens. There's my exponential growth graph. There's the 122, I think. And there's the crossing point. So that's the point that I'm after. I'm after the x value where that's true. So there's actually two ways to do this. Well, if I press trace, then I can get pretty close just by, you know, I'm a little spider on there, and there's my x value. I can get pretty close. Right? Where am I? There's the spider. Notice that it's kind of frustrating because when I go one dot over, it jumps too far. Notice I could go up to this one and maybe get a little bit closer to the intersection point, you know, and that's pretty close, 3.4, but we know that it's actually, you know, not that close. And when I jump back and forth, it's not that close. So this trace technique doesn't work very well, but here's what we want to do. The calculator, of course, is complicated enough that it can calculate that intersection point, and it's using second trace, which is the calc menu, and then I want the intersection. So I'm going to go over and select 5 or hit 5. And then basically I just follow the on-screen instructions. It's asking me, what's the first curve you want to enter? Well, this one? Yeah. What's the second curve? This one? Yeah. Now it asks me for a guess, and notice my little spider is pretty close to there, so I'm just going to press enter. It thinks for a second, and bam, there's the answer. That's pretty good. So the answer is x equals 3.46. Okay, and I'm going to pause the video and write all those calculator steps on there for you. You can pause the video once you see it and write those steps on. Bam. Okay, so there it is. And again, you can pause this and write down the steps, or you can sort of follow along the textbook and learn that way. I'll let you be the judge of that. But this is what we did. We pressed y equals, and we entered the left side in one, the right side in the other, and then we changed the window settings. We hit graph, and then we hit second trace to get to the calc menu and select intersect. We followed the online instructions or the on-screen instructions, and then we found that intersection point. This is one way to do it. Another pretty neat tool on the graphing calculator is the table function. Instead of using a graph to find the solution, we can essentially get the calculator to do a table for us. And the book has its version of this on page 388. It's actually the same example as before, but it's using the table. And this is what you do. Don't need, I press y equals. You still need to put in the function, and we're looking for when this function is equal to 122. We did it graphically before, and we're going to use a table this time. The way the book does it, instead of window settings, you have table settings. You see the TBLSET? So I press second window, and this brings up the table setup menu. And this table is starting at 135, which we're going to start at 0. Just because, and it's going up by 15. We don't want it to go up by 15. Maybe we'll go up by ones, you know. And this is the way the textbook starts it. But I'll show you that this actually isn't very effective, and I'm going to go back and switch this in a second. Because now when I press second graph, and then graph gives me the table. There's the table. There's the inputs. There's the outputs. Now, notice we're looking for when is the output equal to 122? Well, for 3 it's 64, and for 4 it's 256, and we know it's in between there. It's no good, and I can't really zoom in there or anything like that. And that had to do with our table settings. So I'm going to go back to the table settings. Because we asked it to go up by 1, that's why it skipped all those values. So I don't like using this table thing here. What I'm going to do is change this to ask. And what this will do, this will ask us for what value we would like to input. So change that to ask. And all I did was to go over and highlight it and press enter. Okay? And then if I press table, second graph is table. Well, it's blank, isn't it? Well, this is no good. Well, it's asking us for the x values, right? So if I put in 3, there's 64. I put in 4, I know that one's too high, so I know it's got to be somewhere in between. And essentially, I can use the graphing calculator to very quickly guess and check, right? 3.4 is too low. 3.45, 4.5. And I'm going to zoom in on it really quick here. I'm looking for when is this 122? Well, a little bit higher than that. Well, it needs to be a little bit lower than that. A little bit higher than that. And it's really, really, really fast to guess and check on this, isn't it? Look, and I can get very close very quickly using this table method. And so there are the steps to do this this version of the table. And do you have to know both? Not really. Do you have to use the graphing calculator? Yes. At times, you're going to need to use a graphing calculator. Remember, one of these things is going to be sitting on your desk for the exam. So you know, get to be able to use it. Get to know it, love it. I think that's it for today's lesson, though. Indeed, it is.